Hello everyone and welcome to a new topic, and today we are going to start a discussion on vector data compression techniques. And though we know that there are hardly any redundancy in the vector data, but still sometimes which we will see that how redundancy also exists in the vector data, and what are the concepts so far available with vector data compression techniques. So, this discussion we are going to have in much detail. As you know that resampling of vector data is the key for the compression, and basically that leads us to the vector data compression in really narrow sense. So, in this concept of vector data compression, if we think that extract a subset from a set A, which is a collection of points that compose vector graphics. What does it mean is basically here that if I am having village level data of entire India, that might be few lakhs points. Now, I am not really working on the entire villages data set, but I am working on a say for example only for Uttarakhand state. So, why to keep the entire data set with us, and therefore, we can do the subsetting of the data and try to make this subset of course, which will reflect the original data set, which will have the original data set, and within or very accurate as far as possible when we do this extraction from the original data set, and all these points will be possible to use later on in any other our discussion or in analysis. So, that is also one way of taking achieving indirectly a compression. Similarly, we can take example of line data. For example, if I am having a stream network for entire India, there are suppose if you are looking stream network for India, you may find that on the net the stream network for the entire Asia which is available, which has been generated from SRTM digital elevation model and through surface hydrologic modeling. Now, whereas I might be working only in a say small basin or in a large basin like Ganga, and I want only the stream network for Ganges. So, why I should go for that for entire Asia data set, though I have to download and then take a subset of that, extract the subset, and of course, there should not be any issue related with accuracy, and this subset we should be able to use it, process it as and whenever we require for different project. So, vector data, that means indirectly, not in real sense, but in otherwise we can achieve certain compression, but the real compression which we will see that if we by some means if we can reduce the number of these internodes or a number of x and y coordinates. Suppose I am having a boundary of India which was digitized or which was created at say 1 million or 250,000 scale. That means that boundary will have very fine details about boundary of India, especially in coastal regions or in other places also. Whereas my target to use that boundary, and I might be using or preparing a map in which I would like to show the boundary of India at say 1 million or 5 million scale. And therefore, if I keep using that data which has got detailed boundary of India or a polyline or polygon, then there is no use. So, by generalization method I can reduce internodes and make it a simpler boundary, because ultimately I am going to produce on a small scale. Instead of 250,000, I am going to 1 million or 5 million. There I do not require much details about the India boundary. So, that is also we can consider as vector data compression. So, generalization as vector data should also include storage compression and resampling of the vector data. This we put as a generalization, which I have just mentioned, and of course, it will produce the storage compression as well, because less number of nodes when they are stored in a system compared to the original data set, then obviously it is going to provide storage compression as well. Storage compression means here is that less space will be required to store that data. Also, and do not think about only that storing the data. Ultimately, whatever the data which will reside in the GIS database, it has to be used. So, if data itself is having lot of redundancy, and when I am using that data, it will take lot of my processing time or RAM memory even for display of the data. And if I zoom it or do it some operations, then again it will take lot of time too. So, it is always advisable in real practical GIS approaches or projects that first we should decide that how much area I am going to cover in a particular study or project. And once that is decided, a area of interest, a polygon boundary, maybe a natural boundary, maybe a political boundary should be used, and data data using that boundary should be extracted and should be kept separately, so that I will not be using the big data file, but I will be using a subset of original data set. Compared to raster and raster data compression, because in raster you know that sometimes there may be very high redundancy in the data, means many cells or pixels may have the same value, and therefore by some means we can achieve better compression, which we will be discussing also about the raster data compression and different technologies or methods which are available to compress raster data. But redundancy in case of vector data is relatively less, and therefore the same compression may not be achieved. For example, I am having a 10 MB raster file, and if I apply a compression technique whichever is available, which we will be discussing later. So, say I apply X compression technique for raster data compression, I may achieve instead of 10 MB that file may become 5 MB. It depends on redundancy. Every file may not become 5 MB, but a particular file I am just taking example. And same time, if I am having a vector data of 10 MB, and if I apply compression or some other tool which are available to us, then probably I may not achieve 5 MB, I may get even 9 MB or 7 MB, because obviously vector data is having a less redundancy all the time. So, vector data is generally do not have much redundancy, as I have already discussed. However, sometimes with large vector data, I gave the example of stream network of entire India, which was created at a 30 meter spatial resolution digital elevation model, and it is having 2 details drainage network of entire Asia. So, this is what there indirectly we can find the redundancy because of instead of using large file, I will use a subset of the file which belongs to my area of interest. But anyway, whatever the compression, one can think of that and try to achieve if possible, so that our processing along with other data sets become more efficient. Because even retrieval, if I have to retrieve say data certain data or query the system, and if it is large data for entire villages of India, first of all it may take lot of time, and secondly sometimes villages may have same names. One name, say for example Rampur, which is also in Roorkee or in Uttarakhand, and there might be tens of Rampurs in entire India. So, if I have taken a subset of Uttarakhand out of that village data, then chances of getting errors or getting extra information would be reduced. So, that is why this kind of subsetting is suggested. In case of point data, if we consider the say UTM projection, universal transverse Mercator projection, and then this data is described in terms of easting and northern coordinates, that is they are in meters, whereas in case of non-projected data, that is in DD, degree decimal, and this is what we get in latitude longitude. So, both ways are possible. When we go for measurements, and if country is located somewhere near equator, then UTM works very well, and it may give better results about the measurements like area, length and perimeter, etc. So, that is why UTM is important here. Now, when we are dealing with a small area and our area of interest is not big, then we can imagine that coordinate values are stored with considerable redundancy, because if too detailed information is stored, if say I stored a track recorded by a GPS, now GPS by default is set that every second it will take a coordinate, and my movement, my velocity, my speed may not be that high. So, that means I am unnecessarily storing lot of coordinates, and which is not really required for my project, or those detailed track details are not required. So, again I can go for some kind of compression and can reduce the internodes and can get a more smooth line and compressed vector data. So, here is like how to achieve a storage space or save storage space or storage compression, and then define the local origin, like here it has been defined local origin, and then store all coordinates relative to this origin. And in that way also this is basically going back to geometric system, but only for a small area, and this is what the sometimes civil engineers or surveyors do. Instead of using easting northings in case of UTM projection or latitude longitude in terms of degree minute seconds, they are having their own coordinate system, because the area may be 1 square kilometer or maybe 5 square kilometer. So, instead of writing degree minutes that may be the same for a small area, and that means I am introducing the redundancy. So, instead of that we can have a local origin, and then with reference to the local origin everything can be surveyed and plotted. So, these new coordinates having local origin are the similar smaller numbers than the original ones, because original ones will have degree and minutes, but here only with seconds or minute seconds it can be worked, and then it of course it will require less storage space. So, by which we are indirectly achieving a data compression, vector data compression. Now, coordinate offsets will preserve absolute coordinates, which will be used to restore the information when we use this data. That means that I can store somewhere about the the offset of about this information, and then whenever I want those easting northings or geographic coordinates, it may be converted easily. But originally the data can be stored using a local origin, and by which I can achieve storage, vector data storage compression. And now there is for point data we have discussed, the similarly for line features compression, and this procedure for point features can also be applied in a similar manner to line features or polyline features, where only first point is saved and then null coordinates information, and that way all remaining coordinates of each line use the local origin as reference. So, as saying that instead of using easting, northing or geographic coordinates, local coordinates can be created and they can be used in terms of distance like in meters or centimeters depending, and you can store. So, just per point you can, if you can save few bytes, and if you are having such thousands of points, definitely you will store and save some megabytes of data, and that is what it is important. So, when we go for this data compression for line data, then there is a technique which is known as the Freeman coding compression techniques. So, which is achieved by rasterizing vector data. Now, is a kind of reverse process, but nonetheless it will depends on the project and depends on the redundancy. If not much redundancy is there, one does not have to bother about the compression of vector data. But if there is a redundancy and it is taking lot of time, then we should go for such compressions. So, the possibility here for first to rasterize the features, that is line feature in our discussion, onto a regular grid as shown here, that these are the lines which are there, and in background we are having raster grid, and afterward this proceeding with the Freeman coding or chain coding method. Chain coding method has also been implemented for raster data compression. So, when we will discuss that part, that is also will be discussed in detail. So, this compression method, the chain coding method, will only the coordinates of the starting point of each line are stored, because rest of the things are stored as a regular grid, and that way also compression can be achieved. And the increasing number of directional positions from 8, for example 16 corresponding to 4 bits and 32 corresponding to 5 bits, it is possible to enhance the geometric precision, and by which also we can achieve better compression. So, codes can be stored using integer types. As you know that storing integers will require less space than storing in real data or real type or in floating points. That is why also that whenever we choose the precision, even if we have to store data for certain analysis in real numbers, then we should choose very carefully about the precision. For example, if I am storing the pH value of the soil or water in my database, and by default my database is having 4 precisions after decimal, 4 places after decimal, but we know that our instrument and the technology which we are having, we can only measure up to 1 decimal place. So, why to keep 3 decimal places extra in our database for storage, whereas we are not going to have the any values or significant value there. So, that is through better management of attribute data or characteristics of the field or column, format of the column, again we can achieve better compression. Even that attribute table belongs to a point data or line data. So, on all fronts we should work to save space. This is not only saving space, it improves the quality of our data, it improves the our query system, it improves our analysis also. So, redundancy in the vector data or raster data or any data like non-spatial or attribute data may give problem at later stages. So, always it is should be avoided and optimum thing should be kept, whether it is precision for the real numbers or number of nodes and internodes for a line or point data also. So, in this Freeman coding only the boundary is stored, and this is what, that is why it is called this chain code kind of thing. Now, because shape, when we say shape, it means we are talking about the vector data, and once we are having the data in that format, then perimeter, directional analysis and shape turns, it is possible to analyze or estimate their length and perimeter, etc. And this can also be used, this concept, to convert raster to vector conversion. As we know that when we discuss this raster to vector conversion, I also mentioned that currently the technology is not available yet which can automatically do this conversion from raster to vector. Though your software may convert from raster to vector, but it will end up with very poor results. So, whatever the methods which are available so far are semi-automatic with lot of human interventions. And a very well known software which is called R2B, that means raster to vector software, can do conversion, but it has to be trained. And for almost, suppose I am having a Survey of India topographic map in which I am having multiple layers in different colors, and I want to extract only contours. So, when I will scan that using a large format scanner, basically I am generating an image of that topo sheet. That is nothing but the raster. And if I submit that scanned image of a topo sheet to this software which is R2B, then what is going to happen? It will convert, but it will give us very erroneous results. So, what we need to do, basically what we do, that we train each and every contour line. So, we give a start to the software that this is the start of a contour line having value 100. And then the software itself, by identifying pixels having same color characteristics, it will follow and digitize or vectorize. And if wherever there is a confusion, it will stop. Now, when human interventions are required to go and to proceed further, you have to connect by yourself. So, if there is a contour and a 100 value is written here and it is there. So, if I have trained this one, it will keep digitizing till it will stop here, because here it is confused. So, then I have to say that just ignore this whatever written and restart from here, and it will reach to this end. Therefore, there is no fully automatic raster to vector conversion technology, neither software available. But by doing this raster to vector conversion, obviously we are achieving compression, because raster will always occupy the space. So, if at all it is required, then with some limited options we can convert, and if possible that we always require vector data rather than initial raster data, then anyway you will achieve the compression. Now, here the boundaries in this Freeman coding compression will be stored twice. Now, vector data compression, so far the algorithms which are available, this is the classification of that one. So, vector data compression algorithms either targets for the storage compression or resampling techniques, and that also belongs to the generalization kind of thing. So, there is a universal algorithm, and this one you already know about. These two are very famous, JIP and RAR. These are compression techniques, and not only they compress the vector data, raster data, but also any data, image, video or textural data also. But a lot of details about these compression techniques are not available. They are protected, copyright protected, so we do not know about that much. But anyway, they are basically based on this algorithm, which is universal algorithm, which is used. And sometimes if you try on a particular raster file, you may achieve very good compression if you zip it. But on the another same size original raster file, if you try, you may not achieve that compression. For example, the original file, raster file or vector file is having 10 MB space or 10 MB memory requirement. If I zip it, it may reduce to 8 MB. But I am having another vector file for the same area having different theme, and if I compress it, I may not achieve even 8 MB, I may achieve just 9.5 MB. So, depending on the redundancy of the in case of vector, depending on the redundancy of internodes and points, and through which only you achieve the compression. The good part about these JIP and RAR, and lot of utilities WinJIP and WinRAR and such softwares are available. Most of them are free or some license are also there. But the best part here is that there is no loss of data, and that is why they are very popular. I mean, they are non-destructive compression technique. Today I compress a 10 MB file to 8 MB, and then I send via internet or email to some friend, and he can unzip it, and the original quality will be stored as it is. So, this is the biggest advantages by these techniques which are, or these tools which are available through this universal algorithm, and that is why they are very, very popular. Now, there is another way of compressing which can allow us better storage compression is data converging algorithms. So, data converging algorithms are used for mapping and other cast type of this methods, and all these are, as mentioned here, lossless, non-destructive compression techniques. And most of us should always check before compressing any data and deleting the original one. Always check whether it is a lossless or really destructive or lossy. For example, like if I convert a raster data into JPEG, then JPEG is a lossy data compression technique rather than lossless, or I say is non-destructive or destructive compression technique. So, before choosing any compression technique, make sure that it is lossless, unless you are having the backup of original data and you do not care about the quality of the data because of certain purposes, it is just you want to send to somebody, quality is not important, then you can go for lossy compression techniques. But the advantage with lossy compression techniques is that they will allow us to achieve much more compression than lossless compression techniques. And best example I have given about the JPEG. JPEG is a file format as well as a lossy compression technique. Now, for resampling methods, there are traditional algorithms, new algorithms, especially wavelet based algorithms are there, which are becoming very powerful, very useful one, and then optimal algorithms are there. If we go for traditional algorithms, then vertical distance algorithm, grating algorithm, Douglas, and our discussion on GIS. Basically, we do not want to go in much more detail about these algorithms, but the tools, techniques which are available, they are being implemented, like for example, wavelet based or neural network based. So, they are everywhere, ant also, ant colony. So, these are the tools which people are trying in almost all domains, in GIS, in digital image processing or in computer, to train the computers to do certain tasks in a much better efficient way. So, these things are being done. But the important point before I go to the next slide is that lossy compressions are not preferred at all. I will give you one example, though that example from raster data compression technique, which is based on the this wavelet based algorithm, and which is called Mr. SID, MRSID, Mr. SID, and which may allow you to compression of up to 50 times. What I mean is that if I am having a raster file of 50 megabytes, using that wavelet based algorithm, I can reduce to 1 MB. But interesting part here, for in case of raster, that is still lossless technique. And Google Earth has implemented that one, and that is why we get a lot of data very easily coming on our screen through net and getting exploded on our system rather than at the host level. And so that we get a fast display of big images or big data sets. So, a lot of such developments are taking place. I do not want to go further on this, and this brings to the end of this discussion about the vector data compression technique. Just to recap, and that in any way vector data generally do not have much redundancy. But if your project requires that you should have a very efficient vector data too, then one should explore the possibilities of two ways of compression, either going for storage compression or going for a kind of generalization if detailed boundaries or detailed point data is not required, and by which directly or indirectly you achieve quite good compression. Thank you very much.